We're going to continue working with rational expressions and functions. Now we're going to be trying to multiply rational expressions. First of all, let's start out by doing a little bit of review of rational numbers and see how to multiply rational numbers. Remember how to multiply fractions. If we have, for example, a rational number a over b, and we're multiplying this rational number by the number c over d, then the rule that you learned in your previous work is that if you have two fractions you're multiplying, you multiply the numerators and you multiply the denominators, right? And then simplify. And to simplify, as you learned earlier, you're going to be trying to cancel common factors and write the expression in lowest terms. But the rule for multiplication is you multiply numerators and you multiply denominators. Well, it's in exactly the same way that we're going to be working with multiplying rational expressions. So if we have two rational expressions and we're multiplying these, for example, suppose we have 5a to the fourth b squared divided by 16a squared b, and we're multiplying this expression by 14b to the fourth divided by 25a to the third. We'll follow the same rules that we use for rational numbers. We'll multiply numerators, multiply denominators, and then try to simplify. So this is going to be equal to 5a to the fourth b squared times 14b to the fourth divided by 16a squared b times 25a cubed. And there are many different ways of continuing with a problem like this. One way is to try to express both the numerator and denominator in a little easier way so that we can then look at the factors that are common to both of them. So let's express the numerator as 5 times 14 times a to the fourth, but let's combine the b squared times b to the fourth. We're multiplying numbers with the same base, so we add the exponents, and so that is b to the 2 plus 4, which would give us a b to the sixth. Let's do the same with the denominator. We have 16 times 25, and there's no sense in multiplying out those numbers at this point because we may be able to reduce those numbers and we will have smaller numbers to work with. Now we have an a squared times an a cubed, so that means that we're going to have an a to the fifth. Again, multiplying numbers with the same base, we add the exponents, times b. But now we can go ahead and begin simplifying. Since we have a 5 in the numerator and a 25 in the denominator, we can say 5 goes into 5 one time, and 5 goes into 25 5 times. 14 and 16 can simplify by 2. We can say 2 goes into 14 7 times, 2 goes into 16 8 times. So as far as the coefficients here, we're going to have a 7 in the numerator and a 40 in the denominator. Then we've got an a to the fourth over a to the fifth, so let's cancel 4 of the a factors in the numerator and 4 of the a factors in the denominator, leaving a plain a in the denominator. Let's cancel a b factor from the denominator and 1 of the b factors from the numerator, and that will leave a b to the fifth in the numerator. And at this point, you might look again and see, is there anything else that we can simplify by? And we can't. We've got 7b to the fifth and a 40a in the denominator. And that's as far as we can go because we don't know what b and a are. So this is in lowest terms. Okay? So in this case, we were multiplying a monomial by a monomial, and we were reducing. Now, let's consider another product. Remember that product is a word that's used for multiplication. So let's consider another example. And in this case, we're going to consider rational expressions with the variable x. So let's consider 12x minus 20 divided by 5x. And let's multiply this by 6 over a 9x minus 15. Once again, we're multiplying these expressions, and so we're going to say it's going to be the product of the numerators divided by the product of the denominators. And at this point, because we want to simplify this, let's go ahead and try to see if we can factor both the numerator and denominator a little bit further to help us with this. And we notice that 12x and 20 have a 4 in common, so we can express that as 4 times the quantity 3x minus 5. 4 times 3x is the 12x, and 4 times the negative 5 is the negative 20. And we still have a 6 in the numerator. For the denominator, we're going to have a 5x, and now the 9x minus 15, they have both have a 3 in common, so let's factor out the 3, and so we can say 9x minus 15 is 3 times 3x minus 5. Once again, check your work. 3 times 3x is the 9x, 3 times negative 5 is the negative 15. It really pays to check your work each step of the way. All right, so now we've got it in factored form. We factored it completely, and we notice that we have a 3x minus 5, which is a common factor both in the numerator and denominator. We can cancel that out. And then the other factors that we have are 5x and 3 in the denominator and 4 and 6 in the numerator. And so don't forget the 3 we can say 3 goes into 3 one time and 3 goes into 6 twice. So finally then we end up with this expression being an 8 in the numerator and a 5x in the denominator. So this expression is now in lowest terms, and that's what we wanted to do. So for multiplying then, we multiply numerators, multiply denominators, and then we need to simplify. To simplify, we factor if possible, and then cancel common factors. Let's do another example here with expressions that are a little bit more complicated, but the procedure is exactly the same. What if we had t squared minus 49 divided by t squared plus 4t minus 21? And what if this were multiplied by t squared plus 8t plus 15 divided by t squared minus 2t minus 35? Lots of factoring in a section like this. Okay, so now we're going to multiply numerators and we're going to multiply denominators. And so the first step is to say t squared minus 49 will be multiplied by t squared plus 8t plus 15, and that's going to be divided by t squared plus 4t minus 21, and that will be multiplied by t squared minus 2t minus 35. Okay? Now, because there's a lot of writing to do, why don't we just factor right on top of the different factors here. We've got t squared minus 49. That's a difference of 2 squares, so we can factor that into the product of t minus 7 times t plus 7. Right? But now we've expressed the t squared minus 49 as the product of those two factors. So I'll just draw a horizontal line through that. The next factor is a trinomial. If we can factor it into two factors, we're going to have factors with signs in the middle which are the same, and this tells us then that they're both pluses. And so from that we know that the middle term is going to be a sum. Since we have a t and a t to give us t squared, the 8t has to come from the factors of 15, which in this case would be 5 and 3. So we'll have a 5t and a 3t, which will give us the 8t that we need. So that numerator, factor in the numerator, is canceled out. Same thing right here. We have a trinomial. If we can factor it into two factors, the negative here says that the signs are going to be different, so we're going to have a plus and a minus. In order to have the t squared, we're going to have t times t, and then the factors of 21 that give us a difference of 4 are 7 and 3, and we want the larger one to be positive, so we'll put a 7 there and a 3 here. This will give us a plus 7t minus 3t, and so the middle term will be a 4t, which is what we need. So we'll draw a line across that. And finally, the last factor in the denominator, another trinomial. The minus sign here says that the signs will be different, so we have a plus and a minus. We still are going to have a t here and a t in the second factor. And now factors of 35 that give us a difference of negative 2t are going to be 7 and 5, and we want the larger one of those to be negative. So 7, t minus 7 and t plus 5. We'll have plus 5t minus 7t, which gives us the correct middle term, and so we have factored that into a product of two factors. All right, so now that we factor completely, let's see if we have some common terms. And notice that we have a t minus 7 here and a t minus 7 here, so those can be canceled out. So let's cancel the t minus 7s from the numerator and denominator. We have a t plus 7 in the numerator and a t plus 7 in the denominator. We can cancel those out. Then we have a t plus 5 both in the numerator and 1 in the denominator, so those can be canceled out. Finally, then, we end up with t plus 3 divided by t minus 3. Once again, be really careful about canceling the 3's there. Those are not factors. They cannot be canceled out. The same thing with the t's. You need factors to cancel. Whenever I teach this in the classroom, I always write this with factors with capital letters, hoping that students will remember. Need factors to cancel. Okay. So now let's review a little bit what we did here. In order to multiply rational expressions, the first thing that we did was to multiply numerators and then to multiply the denominators. We factored completely, then we canceled common factors, and then we looked at the expression again to see if there's anything else that we can simplify it by.